Alright, y'all, welcome back to Pharmonics. Thank you so much to everyone that has tuned in, subscribed, liked, and such. Today we're going to talk about pharmacy math. I was looking for any and everything I could find to help memorize these equations, and I wish I had a video like this, so that's why I'm making it. The list I'm using is from RxPrep uWorld book and their resource tab. If you don't know these equations and how to apply them in practice questions, then you will not fare well on test day. You must practice math every day. If you didn't get a chance to watch my NAPLEX mistakes video, I'll tell you that I was extremely good at pharmacy math in school, and I saved all of the math memorization for my last 2 weeks of studying. I had all the math equations memorized, but I didn't practice using the equations enough. I got to the exam and was very perplexed by how difficult and not straightforward the math was. So the fact that you're tuned into this video is already a great step. On top of this video, you're going to want to rewrite equations over and over. Quiz yourself or have someone else quiz you without looking and practice actually using the equation. Write down sentences of how to use the equation in a way that makes sense for you, and I'll show examples of how I did that in this video. I recorded this a bit ago and didn't get a chance to edit it and such, so sorry my voice sounds off. My sinuses and allergies were bothering me at the time of recording the video, and I didn't want to delay the video release any further by recording it again. And it'll be in 2 parts, so the video won't be too long because it's a lot of equations, as you know. So wherever applicable, I tried my best to give memory tricks that I used. And there are some equations that I did not focus on because of the uWorld RxPrep Resource Tab. So you will notice the equations that I do not spend a lot of time on, but I did include it for completion's sake. Without further ado, let's lock in these equations. Starting with the convergence and compounding section. So I put all of the drug dose conversions together. So your potassium chloride 10% is going to be 20 MEQ, which is 20% is going to be 40 MEQ. Here's your calcium carbonate, 40%. I don't know why, but I associate the carb, like since it's 4 letters, calcium carb, it must be 40%. And citrate just sounds like, it just sounds small, you know, like half of that, 21%. Not 20%, but 21% citrate. That I is actually going to be a 1. So, yeah. And then to calculate your elemental weight, you just do the decimal version of the percent times the weight. ATM, I'm sure RxPrep didn't come up with most of these acronyms and mnemonics, so I don't know who originally came up with these, so no reference for that. But ATM, aminophylline to theophylline multiplied by 0.8. Now, how can you remember that 0.8? I'm not sure. I've just always associated it together. So ATM 0.8, ATM 0.8. Ferrous sulfate, 20% elemental iron. Same deal with up here on how to do it. 20% elemental iron, 20%. Lithium, 5 milliliters of lithium equals 300 milligrams of lithium carbonate, 8 milliequivalents of lithium ion. I had to write this out a lot. You should be rewriting all of these equations plenty of times, so follow along in that case. 308. 308. But you also have to remember the unit. So 5 ml, 300 mg, 8 MEQ. And it can help knowing that it's the syrup to the carbonate to the ion. The ion, of course, has to be MEQ. The syrup, of course, has to be ml. And you know the larger number is going to be milligrams. Now, I also tossed IV to PO conversions on here on the back of this card. So these drugs are going to be 1-to-1, phenytoin, azoles, levetiracetam, most loop diuretics, and insulin, but not the PO insulin. Levothyroxine is 0.75 to 1. Furosemide is 1 to 2. Metoprolol is 1 to 2.5. These insulin conversions, oh my gosh, I really just wrote it over and over until it stuck because I did think it was very important. So conversion is usually 1 to 1. That's your baseline. Except NPH twice a day. When you're converting from NPH twice a day to glargine once a day, use 80% of the NPH dose. TUJO to other glargine or detamere, use 80% of the TUJO dose. So you should always be looking for common ground, things that are similar, right? These are both going to be using that 80% of the original. So in my mind, I just remember that it's NPH and TUJO that are going to something different, that you need to use 80% of that original total daily dose. Okay, now common conversions. This was my favorite to rewrite and memorize. Quick things, 200 puffs per inhaler. That's just something that's good to easily spit off. 1 pound equals 454 grams, which equals 16 ounces as well. This is called G House. Again, not sure who came up with this, but the G House is a gallon, and there's 4 quarts in a gallon, 2 pints in a quart, and 2 cups in a pint. I forget the sentence that's like, there's 2 cups living in a pint and whatever. Just remember that there's 4 quarts in a gallon, 2 pints in a quart, 2 cups in a pint. Now with all that, once you get this picture drawn out, memorized, if I know a cup is 8 ounces, 240 milliliters, and also there's 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon, then I can multiply to get the milliliters number for each. There's a cup that's 8 ounces and 240 milliliters. That's the only number you really have to memorize for all of the liquid conversions. And you can multiply to get everything else. Should be pretty self-explanatory. If you want to know what a pint is, just multiply this ml or the ounces by 2, and you'll get the number for what a pint is, and so forth. Now, 1 teaspoon equals 5 milliliters. 1 tablespoon is 15 milliliters. I don't know why. This is just really easy for me to remember. It's just one of those things you gotta know. That comes up all the time. 1 meter is 100 centimeters. That's important to know. 1 kilogram is 2.2 pounds. Again, that should just be light work for you. 1 inch, 2.54 centimeters. Vials and pens are 100 units per milliliter. Vials are 10 milliliters. Pens are 3 milliliters, and they usually come in a pack of 5 pens per box. That is just super easy to know, and it makes insulin calculations easier if you can just spit that out. For your units, this wasn't on the RxPrep equation sheet. It can be tricky, you know, situating your units depending on how you do your math. I don't like the, I forgot what this type of math is called when you make it look exactly like this, but I don't like that. So I don't do my math like that. Units can get kind of tricky for me. So this really helped to make sure everything was in the right unit. So I'm sure you guys have heard of this before. It's called King Henry died drinking chocolate milk now. Well, it's actually just chocolate milk, but I added these because we also need to know these as pharmacists. So I added milky milk and now for milli and nano. So it sounds super silly, I know, but you gotta know it. So King is kilo, Henry is hecta, died is deca, and then there's this sort of base unit here. Drinking is deci, choco, centi, milky, milli, milk, micro, now, nano. You're going to be doing +1 going up this way and -1 going this way until you get to milk. Then it turns into -3 and then -3 again. So to convert to each, like if you need to go from liters to milliliters, you move the decimal to the right 3 times. 1, 2, 3. And same thing for here. Okay, and now I'll let you pause and take a look at this if you need more clarification on that. Okay, parts per million. I remember this like depending on which number you're starting off with. Part left, percent right. So it can also help to think of it like if you're going from a big number, which is the million, of course, to the percent strength, which is a small number, then you should be moving your decimal to the left because that makes a smaller number, right? So you just have to know that it's 4 times. Going from big number to small number, go to the left. Small number to big number, you move it to the right 4 times. Now for specific gravity, you just always know that it's grams per mil. 1 gram of water equals 1 milliliter of water. Water has a specific gravity of 1. So basically comparing the density of a substance to that of water. Specific gravity, grams per ml. SGG per ml. Now, interpreting that number, less important to me, but if you want to know that, it's right there. Now to express ratio strength as percentage strength and vice versa, just do 100 divided by the given number. It's the same thing as proportions, but shorter. So for percent strength, just do 100 divided by the ratio. And if you're given the percent strength, you do 100 divided by percent strength, and it'll give you the ratio. And when converting to percent strength, the answer you get is the percent. Don't further convert it to percent. Just making sure you know that. Here's an explanation of how to do a specific problem that may come up. I'll let you pause and read that. All right, dilution and concentration. I liked these for some reason. And it's going to be Q1 C1 equals Q2 C2. Very easy equation here. And that's going to be quantity and concentration. For this, units in the old and the new, concentration or quantity must match. Those units are going to be really important here. So I'll let you read all of that. And it's important to know if a prescription calls for pure ingredient, it's 100%. And all of these here are going to be 0%. That might be really important. And also if you're making a lower concentration, you can also do this for, if the question is how much is added, Q1 C1 equals, in parentheses, Q2 plus X, parentheses, times C2. All right, allegations. You either love it or you hate it. So the high goes high, low goes low, and those both point to the desired. And then low percent points to the parts of high. High percent points to the parts of low. And then you're going to want to set up a proportion here for each. You'll do this for each, the parts of high and the parts of low. You'll divide that over the total parts equals how many grams over the desired amount. And you'll solve for that. There's a specific type of problem that's tricky to me, and I had to write out exactly how to solve that. So I'll let you read that here. If you have any questions about this, put it in the comments. If you've been doing your practice questions, you'll know exactly what type of question I'm talking about when you read it. Okay, osmolarity. I don't like these. And it took me a while to memorize this equation, but milliosmoles per liter, you're going to do the weight of the substance in grams per liter divided by the molecular weight times number of particles times 1,000. And for milliosmoles, you'll do just grams for the weight of the substance. That's the only difference. So be sure to pay attention. And you also must remember percent strength is in grams per 100 milliliters. So you must convert that to grams per liter before you put that in this equation. You can really mess up the whole thing if you don't do that. And also if you're asked about 2 chemicals, do this equation separately for each and then add it to get the total osmolarity. So basically we're asking how many grams out of the compound's actual molecular weight is present. multiply that by the number of particles, multiply that by 1,000, and you got your osmolarity. It's really, really important to have this memorized. One dissociation particle, dextrose, mannitol, and any single ions. So basically the longer ones, dextrose and mannitol, these are long. And any single ions is obviously going to be 1. Calcium chloride has 3, CaCl2. If you want to think of it like there's 2 Cl plus 1 calcium, that's 3. Sodium citrate has 4. The longest one, the longest name here, has 4. And then everything else is 2. So pretty much everything important is going to be 2. KCl, sodium chloride, mag, sulfate, that's going to be 2. So if nothing else, remember that your number of particles in this equation is probably going to be 2. Isotonicity, oh my gosh, hated it, pack it up. The E value is how much X replaces sodium chloride. Isotonicity is figuring out the sodium chloride equivalent. 58.5 is sodium chloride's molecular weight. That can help you remember that. And 1.8 is sodium chloride's I, because it's the dissociation ions is 2. Remember that from the last card, right? Dissociation ions. And that's how you calculate I, because I is 1 for molecules with 1 dissociation ions, and then you add 0.8 for every additional ion beyond 1. So that's why sodium chloride's I is 1.8. And that's why it's included in this equation, because we need the equivalent for the drug. If the question says solution doesn't dissociate, just ignore the I altogether in the equation. These isotonicity questions are tricky. Read the question, double check your units always, and if you have any questions about this, let me know. You might need to reread this a lot, because I did. And I wrote this out myself, so again, if it doesn't make sense to you, just leave a comment and I'll try to explain it differently. All right, getting a little easier here. This is a rapid fire one. Moles, grams per molecular weight. Millimole, milligrams per molecular weight. Milli, right? Milli equivalents. This is so important. It comes up all the time. And you're going to want to know both of these equations to solve for milli equivalents. I know, super annoying. MEQ equals mg per valence divided by molecular weight, or millimoles times valence. And millimole already accounts for the 1/1000th thing, so that's why you don't need molecular weight here. Both equations work, but you really should know both, because you never know what information they'll give you in the question. And for valence, you're going to want to know this. Divalent cations are going to be your calcium, iron, magnesium, lithium. Everything else is monovalent. Minimum weighable quantity. This is such old news, but you got to know it just in case. You don't want to miss this question, you guys. Sensitivity requirement divided by the acceptable error rate. And that's usually going to be 6 divided by 0.05. Don't ask me why, but sensitivity requirement is usually 6, and the acceptable error rate is usually 0.05. But just use whatever numbers they give you. And try to remember that the smallest number, the little decimal, is going to be at the bottom. Basically, what this is telling us is that 6 milligrams, or whatever the sensitivity requirement is, 6 milligrams can be added or removed before the number on the dial of the balance actually moves. All right, y'all, that was a lot. I know. We're gonna keep trucking though. We're going to the clinical section now. That's what I called it. Starting off with the Cockcroft-Gault equation. You guys know this. I know you do. 140 minus age divided by 72 times serum creatinine times weight. And if it's a female, you multiply it by 0.85. This super important. If they're underweight, if you don't know this, guys, you can miss the whole question, because I didn't even regard this at all on my first exam. I just, okay, what's the patient's weight? Put it in. I didn't even consider this. So don't make my mistakes. If they're underweight, use total body weight. If they're normal body weight or less than BMI less than 25, overweight, do ideal body weight. And if they are obese, BMI greater than or equal to 25, use adjusted for the Cockcroft-Gault equation. Just another way to visualize that if you need to pause that there. All right, blood gas. The ABG is usually going to be pH / PCO2 / PO2 / bicarb / oxygen saturation. This chart, you're going to want to know this chart, and then you'll be just fine. You may have heard the term or the phrase respiratory opposite, metabolic equal. But what does that mean? So you have to know this chart. You have to see it in your brain. You know, metabolic is first. M comes before R. Acidosis is first because AC would come before AL, right? So the pH here are pointing towards each other. pH is always pointing towards each other. Now, where the acronym comes in, respiratory opposite, the problem is that the PCO2 opposite of your pH. Metabolic equal, the primary problem, which is the bicarb, is going to be equal to the arrows of the pH. Usually it's provided in the question like labs or something, but you should know what the pH is too. Is it acidemia or alkalemia? Won't spend too much time on this one. Sodium minus chloride minus bicarb equals anion gap. I'm not even gonna lie to y'all, for the pH, I kind of chalked it. If I got a question on this, then it was just gonna have to be for the birds, because I just didn't feel like I personally wanted to spend like time memorizing this when I didn't feel like it would come up. And well, same thing for temperature here. This is on the reverse side of the card. You can look at that if you want to. Oh my gosh, this is a big one here, guys. Absolute neutrophil count. White blood cells times in brackets and then in parentheses above 100, percent segs plus percent bands. You need to write this so many times, you guys. The lower the neutrophils for segmented, which is segs or neutrophils, segmented neutrophils, sorry, the more susceptible the patient is to infection. Segs may also say PMNs or polys in the lab, so look for that if you feel like they didn't give you segs. Gotta know this chart, okay? So these numbers are pretty simple here, but then when you get to normal, it's like randomly 2,200, super specific. So profound neutropenia, less than 100. That is the worst, profound. Distinct neutropenia, less than 100. Now, less than 500 is just going to be severe. Still pretty bad, but it's not distinct, but it is severe though. So less than 500. Double that, less than 1,000, basic neutropenia. You're at risk. And then for normal, 2,200 to 8,000. Time to burn, super simple. SPF times the time to burn without sunscreen. Oh, I actually did write temperature already. I thought I needed to make a new card for it, but here it is if you want to know how to rearrange the equation. So you can only memorize one of them, and then to figure out the other, just rearrange it. Pack your smoke history, super easy. 6 cig packs per day times the years smoked. You guys, we got a doozy here, okay? Insulin carb ratio and correction factor. This took a lot of beating into the brain for me. So your insulin to carb ratio, grams of carbs covered by 1 unit of insulin. That's what we're figuring out. So correction factor for 1 unit of insulin will lower blood glucose by this amount. Whatever number you get, that's how much it'll lower the blood glucose per 1 unit of insulin. And remember too, when you're calculating this, the total daily dose is all insulin, basal and bolus, not just the regular, not just the rapid acting, it's all the insulin. So ICR, and I kind of remembered this as a chart as well. Regular is on the left, rapid is on the right. ICR for 50, correction factor 1500, rapid acting. 50 plus more than what regular is, 500. Rapid acting is also going to be higher for the correction factor, is 1800. Rapid acting is always going to be the higher number for some reason. So if you just think about it in a square, right? Regular is on the left, 450, 1500. Rapid acting, 500, 1800. And the ICR is always first. Correction factor has one less letter, so it's going to have a higher number. Don't ask me why. So, and of course, all of those numbers are going to be divided by total daily dose. And you see I messed up here. I had total daily dose of insulin regular, and I had to mark that out. No, it's all of it, all the insulin. So, and then you could do grams of carbs divided by insulin to carb ratio, and this will equal the number of units of insulin needed to cover a meal and prevent hyperglycemia. All right, not done yet. Correction dose. Blood glucose now minus the target glucose divided by your correction factor that you just calculated before. You also must add the insulin correction dose to the original pre-meal dose. Okay? And this correction dose is going to be the same for both types of insulin. And it's going to be your total units of insulin needed to return the blood glucose to target range. Right, the Friedewald equation. I feel like this came up a lot in practice questions. So, lipid panel is most accurate 9 to 12 hour fast after eating. That's just a little tidbit. The equation is going to be, we're calculating for LDL. So, total cholesterol minus HDL minus triglycerides divided by 5. It's going to equal your LDL. This is not to be used at all if the triglycerides is greater than 400, because it's not accurate. And it'll make your LDL falsely low if the patient is unfasted. Now, just a little tidbit, if your triglycerides is greater than 500, it can cause acute pancreatitis. On the back, I tossed the drugs and supplements that can raise LDL or triglycerides, or both. For LDL and triglycerides, I came up with a little acronym called DIEPA. I know, this is really stupid, but DIEPA for those. Double F for LDL only. And then, I don't know, for triglycerides only, I feel like I heard this a lot, so it was easy for me to memorize. It's those kind of hidden cholesterol things or fat sources that you would think of with nutrition. So lipid emulsions, propofol, clobetasol, and bile acid sequestrants. Those are all going to be kind of hidden fat sources that raise your triglyceride. Mean arterial pressure, you can look at that if you want. You can pause that. Corrective Phenytoin, you can look at that if you want to. Pause it. I also want to let you guys know here too that you don't correct free levels of phenytoin. You only correct bounded phenytoin. Bounded to albumin. Does that make sense? Same for calcium too, corrected calcium. If it's highly bound, a small dose will increase phenytoin by a lot and can lead to a large concentration increase if it's highly bound. Does that make sense? Because if it's highly bound in the blood, it might not be accounted for when you take labs, but it's still there. And when you give another dose, it's going to shoot the concentration levels up very disproportionately. Low albumin, high free phenytoin equals more toxicity. You still need to know that and understand that even though the equation might be given. Right, the classic statin acronym, I'm sure you all have heard this before. Pharmacists rock at saving lives and preventing fat, and the respective drugs that correspond with that. Now, the milligrams is what you need to memorize. 2, 5, 10, 20, 40, 40, 80. Okay? 2, 5, 10, 20, 40, 40, 80. There's 2 of the 40s. There's not 2 of the 20s. Okay? And the 40 is going to be LP. 2 40s for the LP. And the last 3, except the P, must be taken at PM. And the only high intensity statins are what? You should know that. Right, loop diuretics. I came up with, and this is the convergence between each. Furosemide 40, torsemide 20. So this is FF, right? TT. Bumex 1. There's one boombox. And the longest one is going to be 50. Ithacrinic acid. It's a long word, therefore it has a high number, right? Makes sense. This is for opioids drug conversions, and I will link the original video that I got this from. Amazing video. So glad I stumbled upon it. If you're going with the arrow, you multiply, and if you're going against the arrow, you divide. So you're going to start off with your central line IV here, right, in the center. And starting at the bottom, arrow goes here to PO, starting with Dilaudid, goes up to PO morphine. And then from the IV, it goes to the PO. And then this is just an addition if you also need oxycodone. I memorized it all. IV, everything, all these arrows start from the IV going out. And this one goes up. So IV to PO, oxycodone, it's going to be 2. 2, 3, 4, 5. If you can memorize that, then you don't have to remember all those numbers in that chart for the opioids. You know what I'm talking about? Yeah. This is so much easier. And so basically to do that, if you, let's just say you get IV morphine and you need to go to PO Dilaudid, you would take your number, you would multiply that by 3, whatever number you have by 3, and you'll be at PO morphine. And now you're going against the arrow here. So you would divide your PO morphine number by 4, divide it, and then you'll be at PO Dilaudid. And if you need to go to IV, again, you're going against the arrow, so you divide it by 5. Steroid conversions. This is going from least to most potent, therefore highest dose to lowest dose. Cute hot pharmacists and physicians marry together and deliver babies. And here's the respective drugs. The numbers, this is what you need to know. 25, 20, 55, 44, 0.75, 0.6. Both of the P's, PP5, PP55. MT, married together, 44. MT, 44. The pharmacists and physicians have 4 kids because they married together. PP55, MT, 44. And then the last 2 are going to be decimals. And they're pretty close decimals too, 0.75, 0.6. Let's toss this topical steroid potency on the back because I thought it was important, but not all that important. I just kind of read it every now and then. And I really just focused on knowing the very high clobetasol and fluocinolone and the lowest hydrocortisone cream or cortisone 10 over the counter. Also knowing this last point is important too. What makes a patient immunocompromised from steroid use? All right, y'all, that's the end of part 1. Don't forget to check out part 2 on my channel for the rest of the math equations.